So in part 4 of creating the overlapping donut chart, we want to make sure now we have this translation here set, or the translate positioning. We're going to now move it in here, and for that we're going to use the Pythagoras formulas, or Pythagoras formula, sorry. So what we're going to do here is start looking at how do we get basically this here. I set it on 0, 0, but these are the mystery x and y coordinates depending on here, there, and there. So to do this, I'm going to do just here, or not even there, sorry. I have to do it below the translate. So in here, what I want to do now is create, well, what kind of parts of the formula do we need? Well, we will probably need the inner radius, because we need to have the starting point of this triangle. And then we need to know what is the circumference of it. So it will calculate the exact position here. This here is all done with a formula by Pythagoras, and just realize that if they did it before without a calculator, they must have fine, very brilliant minds. Because I need my coding here. I will be using a calculator for that. Alright. So let's look here. We're going to calculate the x position, and we're going to calculate the y position here. What they are, I don't know yet. So I'll just comment this out, and we're going to use now the formula. So we'll be needing, I guess, the inner radius, which we have. We'll be needing the outer radius, and we also need the circumference. If I'm not mistaken, do we have it here? No, I don't have it there. So let me show you where you can find the circumference first. Do console log. If I save that, refresh, open up developer tab, get the arc elements, and then you can see here the circumference, which basically defines how many degree of the angle it's turning, basically, or something like that. So how much it's rotating. That's basically the circumference. So to get the circumference, we can say here constant circumference equals the circumference variable here. This probably will be later on moving it down into a for each loop, because we will have to run through every one of these. But let's get the first value out. So we're going to say here, let's see if we have this correct. Let's try here the x position. So the x position will be equal to what exactly? Well, it will be equal to whatever is the inner radius, and I guess we can say here plus the slice thickness. The slice thickness will be very important because we want to have the number in the center. So we're going to say plus slice thickness. We have this value here already defined, so to make sure that this is prioritized. And then what we're going to do here is multiply by math.cosinus, basically COS. Then in here, what I'm going to put in here is the circumference. We're going to grab this value, put in there. Then what I can do is I can copy this. I can say this for the y position. But the y position works slightly different. Same inner radius and the slice thickness, but we use here the sinus instead of the cosinus. So we say a sinus, circumference, and then if I copy this, put it in there, copy that, put it in here, save, refresh, we're now getting something. Although what we're getting here is slightly off, surprisingly. So let's see, here we have this index, the circumference is that, and most likely I think it's this here. Alright, we're going to grab this. What I want to do is I want to do an undo restore here negative. Just see if that would impact it. Interestingly enough, it is not doing what I expect. Alright, so let's see here, what am I missing? The sinus, the circumference. Let me double check this. Alright, after looking at the code, no problem here. So the real issue is this here starts from this point here, because by default rotation starts with 0. So what I need to do is I need to basically rotate to the very top, to start at the top, or we could do another trick, not sure if it's a very desirable one, is by rotating the slices. I'll do both options so you can choose what you prefer. So we're going here and we're going to say here rotation. I'm going to say here 90 degrees. Or what you can say here 270. So if we do 270, it's basically saying we're going to rotate it 75% like that. No. Is it? Or is it 9 or maybe negative 90? Let's see. There we are. No, that is also not working. Alright, my bad. I'm just so confused. So let me just start all over here. So if we do this here, it's like that. What I want to do is, because I know this is 90 degrees, it starts at this point. So this is basically 270, but I need to move it 90 degrees down. So what I can say here for rotation then of course is 90 degrees. I don't know why my mind is just struggling with it. Anyway. So now it works. As you can see here, this starts to work nicely. And then if this is a desired way to do it, you can do it like that. If you don't like that, I will show you another way later on. What I want to do first is to make a for each loop here. So what we're going to do here is we're going to say just here before the translate, we're going to say data.datasets index 0, or no, sorry, not index 0. We're going to do a for each loop for every data set. So in here, we say every data set index function arrow expression, and then I'm just going to cut. Well, we have to watch how we're going to cut. What I want to do is I want to cut this, but exclude restore. Restore needs to maintain, but the translate should be within the for each loop. So we do this. There we are. Put here a proper indentation. So once we do this, nothing changes really, but what I want to do now is start moving basically this here. We have here these values. They use inner radius, slice thickness. So this is very important. This one I want to maintain. And then here, this here is being used here, but I'll need another one as well, the inner radius, to loop through it. So what I will say here, this will be inner radius main, which is basically the main one. I'm going to put it on here. And the reason I'm doing this is because I'll be needing another inner radius here, but I don't want to confuse you with those same terms. So we have here so now we have a main with a different term, and then we have here inner outer radius. I guess this outer radius here maybe should also be main, just in case. Then this one will be based on the index. Of course, with a constant, you're allowed to do it in here because it's like a block feature. Within this block, it will read it. But just for explanation purposes, it's easier to follow if you see different terms here. So we have the main, and we have here the outer radius. So this here, inner radius, is this thickness. This will work all very nicely. Let's see here. Refresh. Alright, we're getting somewhere, but now I want to move that one here and there. So how do we get that? So we have here the X position, that's the slice, max, and cosinus, the inner radius based on the index, this one, the slice thickness, the circumference. I guess the circumference is a hard-coded one here. I'm going to cut this out. We don't need it there. We need it in here, and we're going to soft code it with the index in there. Save that, refresh, there we are. So the next video we're going to fine tune this a little bit so it will look much better.